If people come and gather here, here's the pipe rock, is Cambrian. The sole thrust is on the on that flat bench in the bracken, the base of the cliff. I've drawn it the red line on the sheet. You've then got then all of the cliff is all the Cambrian, Ordovician Cambrian dollar stones and limestones, but there's a sill, and you can see the sill, that yellow sill cutting through the black layers. Can you see over there? Yeah. And that is this rare type of ultrapotassic rock called vodgesite. I don't know if anyone in the group.
What's the word again?
Vodgesite.
Vodgesite.
Yeah.
It's French.
Charlie, would you tell us?
Yes, vodgesite is an unusual rock. It's yellow mostly because I think the hornblende is the mineral that kind of makes that yellow. But it has a mixture of albite, hornblende, and some augite, pyroxene. And it's an unusual rock because that combination is very uncommon in nature. So,
thank you so much. And then that's not all that we have here. If you look up at that cliff there, this is picture 2 on my handout, and I've drawn these white dotted lines on the picture. Just to give you an idea, these are all a whole load of is this cross section here with a whole load of imbricated thrust holes. It's all just a stack of thrust holes. Dum 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 dum. So what you have is the sole thrust is this sort of is this basal unit here, and this time it's within the Cambrian. So you've got the Cambrian limestone is thrusting over the Cambrian pipe rock, but then within the limestone it's a whole massive series of imbricated thrusts. And that's not all. If you turn around behind you, these are all glacial features. It actually talks about it on the board. I'm not sure.
Drumlins?
I've actually forgotten if you would call them drumlins or what you'd call them.
All right. So today we're looking at Cambrian, and right here is the pipe rock, which is Scolithos barrows, and up the slope is our old friend, the Cambro-Ordovician carbonates. We love them in North America, the Ellenberger, the Arbuckle, the Knox. Here they're called the Durness, and they're limestones and dolomites. But interestingly, about halfway up, there is a yellowish band. It's a vodgesite sill, which is a sodic enriched intrusion, and you can see it's a layer over in the middle of the carbonates, and then off to the left is thrust faults. So they're imbricate thrust faults, and so if you see there's inclined angularity this way, so there's a sole thrust and then there's a bunch of imbricates, and as we turn around the valley we have this incredibly glacially widened U-shaped valley from Pleistocene glaciers.
What are we standing on? We're standing on
on asphalt.
an asteroid. It's still there.
This is a tour. I was going to show people this if you want to gather. This is a simplified geology map of the area. It's a bit more simplified. You can buy it in the gift shop that we go to later on if they've got it for sale, and it just simplifies it a bit. But basically, we are here on this Caledonian sandstone, and we are where's the right? But anyway, we're looking back this way. I'm just trying to do things upside down in my head. So, yeah, come along here. We're here.
Could we orient the map?
Can we orient the map?
Yes.
So basically, we are here, and And we're looking directly at that mountain. So that mountain's the head of that. So it's orientated like that. We're looking. So what you're seeing is all of these mountains. These are all mountains which are the Caledonian sandstone. So they're the 1 billion year old rock sitting on top of this 3 billion year old rock. And these were the eroded remains of the Grenville Mountains. And what has been voted is that these foreland mountains, these Assynt mountains sitting on this basement, it was just voted by geologists in Britain to be kind of like the #1 popular geosite in the country. Just because people find that just so amazing that you've got these mountains just sat there. And actually, they're a little bit hazy right now, but sometimes that view can look really very, very, very spectacular. But anyway, that's what I wanted to show you. And of course, the Moyne Thrust is all behind there, so we're beyond it now. And all this area where we are, the Caledonian's been eroded off. But when we get to Clactol, we get back to it. And the tektite is here, but the boulder is on the contact of the two. So that's where we're coming to now. And then we're going to come back, and then we're going to carry on north up here.
So what's the rocks on the other side of the road? They're the
Lewisian gneiss. The 3 billion year old rock. So if you we're going to have plenty of time looking at it, but elsewhere. But you can just see it here as well. And that, directly behind you, you see there's a whole bunch of glacial striations on the Lewisian rock there as well.
You're right.
We'd have known that when we were on Kelly's Island, dog.
Yeah, I'm going to show that picture later.
Okay.
No, what? Sorry.
It's a picture
Massive.
of Lake in the Lake
Area. There's the
Erie.
island,
Yeah.
Kelly's Island.
I'm going to move out of your way in a second. I'm just going to put
Go
my
ahead,
hand
Charles.
Okay, so here we are. This is our first contact with the Lewisian gneiss. It's 3 billion years old, and we're just really happy to see this old rock.
Okay, so this is the Lewisian gneiss at Assynt. You can see some of the lineations here.
Yes.
Oh, yeah.
So those are the glacial
That's
striae.
You know, this is how Charles and I both got started in geology. We started with striations on the Manhattan schist in Central Park. You look just like that.
Our instructors made everyone go to the park and look at it. There it was the Manhattan schist, which is I think about 1 billion years. This is
That's
3
right.
billion years, but the idea was that the glaciers scratched them, and if you felt them like I'm doing here, you could determine which direction things were going.
And so the question from our instructor was, can you tell from which direction the ice came and where was it going?
Wow.
How do you do that when
Well-
you look at it?
Well, you know it's
Well,
this way.
If it's flowing this way, it's smoother this way, and if it's rough, it's
Going the
that's
other
the
way.
opposite way. And it was a very tactile thing, and that's what made the light bulb go on for a lot of people when they were in Geology 101 in New York. That's what you would do in Central Park here. I'm sure people have the same experience. They can touch a 3 billion year old rock and then all the way up to the fracturing. So the
You're such a slave driver. No.
Take it away. Good. Yeah. All right, you gotta go get a piece. So